Previously we solved equations using square roots, but we can solve equations by taking really any root, the nth root of both sides, whatever's necessary, cube root, fourth root, fifth root, in order to get the variable out from that exponent. So typically we're going to isolate the variable and then apply the root. Now one thing that we have to remember is when we're taking the even root of both sides, I need to put a plus or minus in front of my answer, because when I raise that number back to that even root, the negative sign will disappear. So my answer could be positive or negative. We also have to remember that we can't take a square root or a fourth root or a sixth root of a negative number. So if we have x to the fourth equals a negative or x squared equals a negative, that problem has no solution, or we're going to have to use imaginary numbers. When taking an odd root, however, we can take the odd root of a negative number. So for example, the cube root of negative 8, sorry, that should say negative 8 there, is negative 2. It's not plus or minus, it's just negative 2. Because if I remultiply that, negative 2 times negative 2 times negative 2 gets me back to negative 8. Just like if I take the cube root of positive 8, I only get one answer. That's going to be positive 2, because 2 times 2 times 2 gets me back to 8. So for that reason, we can take the cube root or fifth root or seventh root, an odd root of a negative number, and we do not include a plus or minus on those, just in front of the even root problems. So taking a look at this first one here, I'm going to start off by isolating that x to the fourth. So I'm going to divide both sides by 16. So I end up with x to the fourth equals, now that doesn't divide evenly, but I'm not going to put that into my calculator and get a decimal. I'm going to leave it in this fraction form, because I can see that I'm going to be able to take the fourth root of both of those numbers and it's going to work out cleanly. So that's exactly what we're going to do next. So I'm going to take the fourth root of both sides. I'm just going to rewrite it so we can see it. So I'm going to take the fourth root to match the exponent that's on the x. If it was a cube root or a cube, I would take the cube root of both sides. If it was squared, I'd take the square root of both sides. So here the root and the exponent cancel each other out, so I end up with just x. I am going to need a plus or minus in front of my answer on this one because I am taking an even root of both sides. And so now how do I take the fourth root of 625? Well, I'm going to need to factor tree that. Now I know that 5 divides in evenly. I also happen to know that 625 is 25 times 25. So that's how I'm going to factor tree that guy. Now that's not good enough to be able to get something out because I need 4 of something. So I'm taking the fourth root, not a square root. So I need 4 of something, not 2 of something. But I can see that I'm going to be able to factor tree each of those 25s into a couple of 5s. And so now I have a set of 4 5s, so I'm going to be able to get that out as just a single 5. So I'm going to have in the numerator of my answer, the fourth root of 625 is just 5. Then I'm going to do the same thing for the 16. So I know that 16 breaks into 4 and 4, but I don't need a pair of something. I need 4 of something since I'm underneath the fourth root symbol. But fortunately enough, these factor tree into a couple of 2's. So 1, 2, 3, 4 2's. So that means I'm going to end up with a 2 in the denominator. So my answer here is plus or minus 5 over 2. So in our next example, we've got a little bit of work to do to get that x cubed by itself. So I'm going to start off and I'm going to subtract the 18 from both sides. So I get 2x cubed equals negative 36 minus 18, so negative 36 plus negative 18 gets me to negative 54. So now before I do anything else, I'm going to divide both sides by 2. So I get x cubed equals, so negative 54 divided by 2 is negative 27. And so now that I have that x isolated, I'm ready to take the root of both sides. So I'm going to take the cube root of both sides to match the exponent that's on the x. So I'm taking the cube root of negative 27. Now again, we don't have any imaginary numbers or anything like that we have to deal with because we are allowed to take the cube root of a negative number like what we saw here. So the cube root and the cube here cancel each other out, so I get just x. And then over here, I need to figure out how I'm going to factor tree this. Well, first of all, my answer is just going to be negative. So I know that much because a negative times a negative times a negative will get me back to that negative 27. And then if I factor tree that 27, 9 and 3, and then 9 is 3 times 3. So again, I'm not looking for a pair of something underneath the root symbol, but a triple because I have a cube root on this one. So here's my set of 3 3's. So my answer in this case is going to be negative 3. So again, I can verify that if I multiply negative 3 times negative 3 times negative 3, negative times negative times negative is going to be a negative. 3 times 3 times 3 is indeed 27. So I get negative 3 as my answer. So in our next example, I'm again going to work on isolating the x to the fourth before I try taking the fourth root of both sides. So I'm going to start off and add 4. So I get 16 equals negative x to the fourth. So we think of that as a negative 1 times x to the fourth. So before taking the root of both sides, I'm going to divide both sides by negative 1. So I get x to the fourth equals 16 divided by negative 1 is negative 16. And so now at this point, I'm ready to take the fourth root of both sides, but this one's a showstopper because I can't take the fourth root of a negative. So I can only take the odd root of a negative number. I can't take the even root of a negative unless I end up with imaginary numbers. And for our purposes here, we're just going to forget about those. We're just going to deal with real numbers. So in this case, we're going to say that we've got no solution. So in our last example, we don't have just the variable being raised to the third power, but we have an entire expression. And so that doesn't change anything for us in terms of we're going to have to take the cube root of both sides. It just means that after we do that, we're going to have a little bit of work that we need to do. So I'm going to jump straight to taking the cube root of both sides. So we've got the cube root of negative 27 over here on the right. So on the left, the cube root and the cube cancel each other out. That's the whole reason that we do that. So we get x minus 6 is left behind. Now on the other side, we saw this previously already, so the cube root of negative 27 is negative 3. So now my last step is to isolate the x by adding 6. So this time we're isolating the x after, not before, we take the root. So we end up with x equals negative 3 plus 6 is 3. And as always, we can always check our answer by going back to the original problem and making sure that it works. So if I plug in 3 for x, 3 minus 6 is negative 3, negative 3 cubed, so negative 3 times negative 3 times negative 3 does indeed equal negative 27. So if we have any doubt at all, we can always go back and plug our answer into the original equation and check to see if it works.